By the way, I'm very happy to take questions. If you guys have questions during the presentation, feel free to ask, and I'll answer them. So, big data in Excel. The first question here is, what is big data? And this, big data is a buzzword. It's used all over the place. This is my favorite definition. Big data is defined as anything that doesn't fit in a spreadsheet. Man, tough crowd. So you guys are all developers. You all know that big data is a very specific thing. There are a lot of things that don't fit into a spreadsheet but are still nowhere near big data. However, for a lot of the people you work with, the non-technical people that make decisions and use data in a lot of their decisions, so people like traders, analysts, maybe quants who don't have quite a technical background, this is actually the case. Like, they can either, if they're doing data analysis, they can either fit their data into a spreadsheet and work with it, or they just can't use it at all, right? And then they have to come to you. And now, with sort of the preponderance of big data, and more specifically just the growth of data in general, people, non-programmers, are much more commonly running into data sets that they can't handle. So one natural question is, how much data can Excel work with? It's more than you might think, right? Which is what I'm going to talk about. Before that, though, I'm going to talk briefly about what's the general framework for big data. How do non-programmers deal with big data? The surprising thing is, they actually do the same thing that programmers do. Just they maybe don't think about it quite that way. Right? So you guys may have heard of MapReduce. Actually, I imagine you guys have heard of MapReduce. MapReduce is a couple different things. One thing is, it's Google's framework for dealing with big data, which is the predecessor to Hadoop. And it's this like really cool project that lets them deal with petabytes and petabytes and petabytes of data. I'm actually not going to talk about that. I'm going to talk about MapReduce, the concept, which that was named after, which is how do we deal with a lot of data? The answer is you map, filter, and reduce. These are basic programming concepts. And I'll go through them one by one. So map means you have a bunch of data, a list, could be a very long list, and you run one calculation over every single item. When you translate this to Excel, that just means running one formula over an entire column. This slide is misplaced. So you can see over here, this is how a non-programmer would do this, right? They have a column on the left, they put in a formula on the right, and then they just run that down the entire data set. So that's mapping the same way that you would do it in Lisp or in Hadoop or in anything else. The next thing is filter, which is if you have a big data set, you might not want all of it, right? So you go through and you pick which rows you want to keep. You can do the same thing in Excel. If you're fancy, you can use some ifs and some products. If you're less fancy, you can just make something that doesn't tabulate whatever values you don't want, right? And then the last step, the step that actually takes your entire data set and gets it to something that's usable is reduction. So this is taking an entire list or an entire column and boiling it down to one number, right? And you can see this here. This is just taking the average of the entire column. This becomes really important when you have actual big data, because unlike here where you can look at all the numbers, if you have 1 billion rows, you couldn't meaningfully inspect more than 500 million of those by hand, right? So you run into a problem. Any questions so far? No? Okay, awesome. So, right, back to the central point. How much data does Excel handle? 100,000 rows. 100,000 rows will fit in Excel, but it'll be pretty slow. This is the sort of thing that like your analyst friend will turn it on and then go get a cup of coffee and come back like 15 minutes later, and then it'll be done and they can use their computer again. But it's manageable. And there are a few best practices that are good to adhere to actually make the thing scale and work. And essentially, it's MapReduce. So start with a sample of your data. right? If you have a giant spreadsheet that takes 5 minutes to run a calculation, maybe don't work on it like every single time you need to change something. Operate on the columns. Don't go item by item and sort of just haphazardly put things together. And then reduce the results into one meaningful thing. Right, so map, filter, and then reduce. The other thing you can do is pivot tables. Pivot tables are really cool. And as a developer, I didn't really understand what these did or what they were for and why I wouldn't just use SQL. But then someone paid me to figure it out, so I did. And basically, this is just a bunch of group by statements that you can drag around with your mouse, and then you pick what aggregations come up. This is a pretty powerful tool. If you know what you're doing, this might actually be faster than writing SQL. And for the people who don't know SQL, this is certainly a lot faster than learning and then writing SQL. Right, so it has a bunch of cool features. If you haven't opened Excel and you own like a Windows box, try it out. It's cool. You can drill down. You can do all sorts of different aggregations. It's really nice. It's good for presenting reports. Your friends will be impressed. It's something you can mention at parties. Okay. Next question. Okay, we can deal with 100,000 rows. 1 million is sort of the breaking point. That's the row limit. How do you deal with 10 million rows? Right, this is not a big data set. This is maybe 100 megabytes. Something that you can come across pretty commonly, but the non-developers in your life will not be able to work with it. However, you can still do a lot of things with it, like on a machine. You don't need to buy a server. You can easily run it through a Python script or R or whatever. I'm going to go with Python for this crowd. Okay, so one of the things you can do is if someone just wants to inspect the data, you can store it outside of Excel and have them connect to it somehow and browse it in that sort of familiar interface. If they actually want to build something on it, probably they don't need to work with the entire data set. So they can filter it down first outside of Excel, bring in what they need, and work with it there. For modeling, if they actually want to build something on top of the entire data set, that's a little more complicated. And I would advocate using Python. Any questions so far? OK. So how do you store something outside of Excel? One thing that works really well is a Power BI tool. So Microsoft has this whole suite of BI tools tacked onto Excel, in particular added on to Excel 2013, that let lay people work with larger and larger data sets and do some really cool stuff. So the very basic way to work with this is set up a SQL database and use something called Power Query to browse it. Right. So Power Query looks like this. Specifically, what Power Query does is it lets you just like connect and browse a database, make it look very familiar, and give you like a nice GUI interface that normal people will be able to work with without having to use SQL and without having to use any code. Okay. For modeling, I would say use Python. This is what that looks like. So this is our product, Data Nitro. And basically what Data Nitro lets you do is automate Excel with a Python script. So one thing in particular that you can do is basically set the script up to run as a backend and use Excel as a front-end GUI. Non-developers tend to like this because they have access to sort of all the things they're familiar with. Developers tend to like this because they don't have to use VBA or just like print everything out to CSV and load it into Excel. So I'm going to dive in and show you guys what that looks like a little bit more. Okay. So, as you guys all know, this is Excel. This toolbar up here is Data Nitro. So the way that you get that there is you can go to our site, you can download, it's just a like exe installer, and And when you run it, you get a plugin to Excel, and you get this, this toolbar that lets you run code that executes directly against your spreadsheet. There are a couple of different ways this works. The easiest one, or the easiest one to get started with, is just using a Python shell. So what do I mean when I say Python? This will run any Python distribution that you guys have on your system. It works with regular CPython, so just what you get from python.org. If you're using Anaconda or Enthought or anything like that, you can just point to that distribution. It'll work. It has all of your libraries. So for example, this will work. Right, so now I can use NumPy with Excel. So if someone asks me to run some sort of math, I don't have to code it up myself. I can just use something that's pre-built. Okay, how does it actually work with the spreadsheet? We built a very sort of simple API and injected it into the shell, specifically into the global namespace. This bothers some people because you don't import anything, but it also makes it a lot easier and more readable for people that might not be that familiar with Python. And this is what it looks like. Right, so the syntax is super straightforward. It's meant to be easy to write, easy to read. The goal is for someone who knows Excel, maybe a little bit of VBA, to be able to get up and running with this very quickly. Yeah?
Could you leave that window over?
Oh, yes, sure. Is that better? More? Okay. Hold on. Let me sort this out. Okay. Cool. So you can write data to the spreadsheet. You can read data from the spreadsheet. You can write more complicated objects. So this is all sort of stuff that you can do with Excel as it is. It's pretty straightforward. Yeah?
Is it using whatever sheets in focus? Or?
Right, good question. The question is it using whatever sheets in focus? In this, by default, it is. So when you just pop up the shell, it'll start running against whatever the sheet is. You can specify which sheet you're running against, and you can also change the default. Yep.
This is only available by the plugin that your company has developed, right? I can't just...
Yes. The question is this only available through our plugin? The answer is yes. You guys can go, you can try it out. There's a trial. We're also going to be giving out a couple licenses at the event in the raffle. And if you're a student, we have free student licenses. So you can send me an email and we'll get you set up.
Well, we're all students.
That's not what I meant.
Is it only for Windows?
Yes. Is it only for Windows? Yeah. So if you guys use Excel on a Mac and you use it extensively, regardless of whether or not you use Data Nitro, I would highly recommend installing a virtual machine and running Excel there. It's just going to give you a much better experience. I actually have a Mac, and that's what I'm doing. The Mac version of Excel is Microsoft just for some reason doesn't put as much effort into that one. Great. Other questions? Okay. So let me show you some of the kind of cooler stuff that you can do that is maybe a lot harder to do by hand. Right? So one is, in addition to reading and writing values and formulas, we have access to all of the properties that come in Excel. So you can change formatting and do a lot of other stuff that people typically do by hand. Right. So this is an example of something that would probably be this is what a Goldman Sachs person might assign of first year analyst intern, or if any of you work at Goldman Sachs, just substitute a different company, right? To build out this sort of gradient, which is pretty hard to do by hand, but you can do it really easily. Right. Slightly more seriously, you can do all sorts of things that are just Excel isn't set up for. So here's another pretty basic example. Right, so this gets you a nice diagonal of squares if you're like making a multiplication table or something, which is also a super common use case we find. Yeah, and this is just something where if you were doing it on your own, you would have to go out and do it by hand, right? And this is a trivial thing, but one thing that people do very often is, let's say you're pricing an option and you have a binomial tree. People sort of hack it with like a triangle, but that's pretty hard to read, right? Like it's really straightforward to set up an actual tree that does actual options pricing that someone can look at and understand easily, or just like any other flow you can come up with. The other thing that I think is really cool, for those of you who've worked with VBA, you'll know that VBA freezes Excel while it runs. If you have a long script, you know, that 15-minute coffee break can easily turn into like a half hour of waiting for the thing to run, and then like restarting your computer and then trying to run it again. One nice thing about Data Nitro is we actually don't block Excel, so you can just keep running, right? And specifically, one of the things this lets you do is, this is how you accomplish like having Excel as a front-end GUI and having something running in the background. Your user doesn't have to like click a button to recalculate. They don't have to keep thinking about, you know, what does what. They don't even necessarily need to know that there's any code running, or at least they don't have to think about it. They'll just see the results. Let me show you like a very basic example and then something a little bit cooler. Okay. Can anyone tell me what this does? Anyone have a guess? No? Okay. What this does is it's just running a loop, and anytime you type something into the first cell, it'll get printed out. Right? Why is this useful? It's an interactive script. And this doesn't just work with sort of users typing things. This works with, if I have a formula in here, right, it'll work with that too. So anything like that will work fine. So you can set up something that will like monitor what's going on in your spreadsheet and do things based on that. Maybe, you know, update a database somewhere, submit a trade that's hopefully being then reviewed by a person, things like that. Yep.
So suppose you had 10 different cells you wanted to monitor. You need to have 10 different Python threads all running those?
The question is, how do you monitor 10 different cells? It depends. You can have 10 different Python threads, or processes, more accurately. You probably don't want to do that, and you would probably monitor them all in one process, but it really depends on what exactly you're trying to do with that data. Yep. Sorry. Can you respond to worksheet events? You can't directly respond to worksheet events. You can call back and forth from VBA. This is actually more for like backwards compatibility and legacy uses. So if you're working somewhere where you have a large VBA code base, you don't need to start writing everything from scratch. You can call into there. That can call from Python and sort of update new code that way. So specifically, you can just write new code in Python. You can get to events through that. That is, you can set up an event in VBA and call Python based on that. The reason we don't have native support for events is we don't find it super useful once you get into things. So just like, if you guys really want something, you can contact us and we'll probably build it, but there's usually a better way to do it. The exception is we do have the ability to open something when you open a workbook. So you can really build like applications that'll just like, someone will click a spreadsheet and anything can happen, right? They don't know what. It's just gonna like run a model immediately. There's a question over here. Yeah.
The similar way, if you have any change in any of the cases,
Sorry, could you say that one more time?
if you are to track any change happen across all the sheets, any cells, like I want to track changes within my sheet.
Yeah. So is there a good way to track changes across the entire sheet? You can do that. It can get slow. It depends on what exactly you want to do. OK, cool. So this is a very basic sort of just how does it work. This is a better example of something one might actually build. So this is an interactive stock ticker. When you change the stock in here, and so you'll notice that shell is just running in the background. There's actually ways to make that black box not pop up as well. So if I change the stock ticker, right, this will update and get data. Anyone have a favorite stock that they want to know how it's doing? What is it? How TSLA? Oh, no, that's not what I wanted to do. OK, so there you go. And you get a nice graph, too. It's impressive. Yeah, so this is the sort of thing that once you start putting everything together, you can build these sorts of frameworks. And this is running pandas in the background. And you can use pretty much anything that pandas can do. Right? So if you're running some sort of stats, if you're running some sort of regression, you can code that in a language that you're comfortable with. And you can give that to someone where they can change enough variables that they'll be able to work with it and pretty much run whatever analysis they want, as opposed to, say, call you back 20 minutes later and ask you to change the time frame on it. But at the same time, they don't sort of start messing with the innards that really they're not going to be able to work with because that's not what their specialty is. Yeah?
Things like summary stats that pandas have.
Yep.
Can you just say, all right, on this cell, I want to just dump the summary stat?
Yep. So the question is, how do you get the summary stat in here? And actually, I can show you. So, right. If you look at here, this is where the summary gets written out. So that's just saying .df is a sort of really short way to drop a data frame into a table, or just like a block of cells. So this is literally just saying write the tail into the table starting at A4, write the head into the table starting at D4, and then write the summary, which you get with df.describe into G4. It's very, very straightforward, and that's really the entire point. We're not trying to have you guys rewrite anything. We're trying to make this as easy to work with as any other Python library, right? Think like requests or something. Other questions? Yes?
This might be getting back to events.
Yep.
If you wanted to do kind of more interactive plotting, if you had a list of stocks and you wanted to select and then plot the price here or whatever.
Yep.
For it, that you would need to plug back into VBA.
So the question is, what do you do if there's a list of stocks and you want them to select which one gets plotted? I actually have that exact demo, but I'm like only 95% sure it runs, which means it'll just fail if I pull it up right now. But you don't have to plug into events, so you can get surprising, like you can find where the person is clicking by checking the active cell. So you can get pretty far with just doing that and not needing to listen for events directly. So that's maybe another event that you can sort of get, which is where is the user pointing to right now. Other questions? Yes?
I think I need to be restating that question. But suppose I have a list of stocks that I want to overlay.
Yep.
So let's say I do it in one column and I have the cell, whatever you have Google, then now I want to add a third one. How do I notify the script that somebody has entered?
Yep. OK, I'm going to attempt to pull up this demo, as now that's the second question. We'll see what happens. So, right, this is exactly the thing that I think you guys are talking about. OK, so this is, oh, the list is not visible. Hold on. OK, so this is a list of tickers, and it goes into a chart, and it also has the price of the stock here. So if I click here, this will update. If I put something else here, hold on. Right, that'll update as well. And I can actually put as many things as I want to in here. How does that work? In this case specifically, it's just checking what column you're in. And if you're in the first column, which is where, if you give this sheet to someone, you would tell them, put all your tickers in the first column. That's how it would and that's how it knows that something's been added. Right? It's not like VBA where you have like a set number of buttons and you need to like add one each time you add an action. This is a lot more dynamic because you can, essentially at runtime, have the user add additional interactions. The other thing that I didn't mention is we also have the ability to expose functions inside Excel. So this getPrice is not a native Excel function. It's actually a quote to a call to Yahoo that gets the price from there. And that'll just work with any Python function.
Question.
Yes.
So you can build that type of function in Excel with VBA too. So how does it know
Yes.
to go to Python getPrice function?
Yep. So the question is, you can build this in VBA too. So how does it know to use the Python code? Basically, if you load a Python script through our toolbar, like in the appropriate way, it'll get the functions from there. If you have a function in VBA and a function in Python with the same name, you oughtn't do that.
Right.
Yeah, that would be confusing, and it'll have to like resolve name collisions somehow.
Right. So basically, if you load it in, though, it's there. And it's
Yes.
for Excel.
Yep. Yes.
Follow-up question. So is any function available, or is there some special markup to start the one?
Is any function available? Any function is available. The way that you load it is you give the file a particular name, which is functions.py, and then you load it in that way. And then any function in that file will be exposed directly to the sheet. So one of the goals is there are similar things that let you use Python with Excel. And one of the drawbacks there, in my opinion, is you have to add a lot of markup and sort of tell the program what goes where and what runs how. We're really trying to avoid that. The goal is to make this super simple for someone who doesn't have programming experience outside of Excel and VBA to get started with. So for that reason, we chose to avoid things like decorators and other, sort of somewhat esoteric things. Yep.
Can I publish this set of functions and then give it to an end user who does not need to use DataNitro?
Yeah, so can you publish the set of functions and give it to someone who does not have DataNitro? The answer is no, unfortunately. So to run a script or to run Python functions, you actually need DataNitro to connect the Python interpreter to the spreadsheet. There are ways that we can put together, we can build a specific plugin that will just have just your functionality, but the end user, and you would talk to us about that, that's like not something you can do on your own, but we're happy to work with people to do that. But the end user still has to install something to add that functionality. However, if you just generate a static spreadsheet that you want to show someone, like if you build a report or something, that's just a regular Excel file and you can send it to them. Yes?
How does distribution work? If I have a library of functions that I built and I'm updating it and I have to distribute it to people?
How does distribution work? One of the issues with distributing or deploying VBA is that the code lives inside the spreadsheet. So that means whenever you send an update, you have to get every single person to update their spreadsheets. In practice, this just doesn't happen because they've made some modifications. So what's different about DataNitro is the scripts aren't, or the code itself is not stored inside Excel. The code is stored just like in a regular Python file. So the easiest way to deploy it to a team is actually just put it on a shared drive that everyone has access to. And then whenever you update that file, that'll update for everyone. You can also put it on Git. You can do other things, and we work with that as well. But like that, just the shared drive is a super simple solution if it's like 2 to 5 or 10 people. Other questions? Yes.
In the code you showed us, I saw a lot of cell references, D2,
Yes.
D4. I imagine that can get quite messy.
Yes.
How do you deal with that?
In the code, there were a lot of cell references. How do you avoid having that many? So there are different ways, but it's basically how do you build any GUI, right? One easy answer is you can use named ranges. So if you're really having a lot of references, that's a good way to be able to look at the code and know what exactly is going on, rather than have to remember what's A4, what's B4. This also gives the advantage of your user can move the named ranges around if they're careful. The honest answer, though, is actually kind of no matter how complicated your script gets, there's only so many UI elements that the person is going to interact with. So if for a short script, like it's a large percentage, but it's sort of a O of 1 growth, right? So you can have 10,000 lines of Python, but there's still like a very thin UI on top of it, or the person just wouldn't be able to handle it. Yep.
So Data Nitro has asynchronous computation. You have to marry it with some kind of sequential VBA macro that you already have. How do you do it?
Yep. So the question is, Data Nitro is async. How do you get it to be synchronous so you can run it with VBA? The easiest thing is to call VBA from inside the process, and then that'll wait for the macro to execute before it continues, because that's single-threaded. Yes.
I'm curious, thus far, who are the main adopters of this? Is it people who are working on their own spreadsheet, or is it people who are supporting other people who are really only familiar with Excel?
Yep. So the question is, who uses this mostly? And the answer is it's the latter. It's people who have to interact with someone who uses Excel, right? Generally, there are some cases where you're working with a spreadsheet and you can speed up something simple. But as a developer, you're probably not going to write a 10,000 line program that integrates with a spreadsheet. You'll just be able to write output. If you really needed, you would probably prefer it as a CSV. But if you're working with a colleague who can't use those sorts of tools and really needs it in Excel, that's where this has the most use. Okay. So much for the demo. I will be around after if you have any questions. My co-founder is here too. If you have more technical questions, you should really, try to confuse him. Okay. So moving on, right. So that was how you deal with sort of 10 million to 100 million rows. You can actually scale it up quite nicely, but at a certain point, you are going to hit sort of more than you want to deal with in Python, right? So 1 billion rows, which is still manageable, but not great. How does that work? There are a couple of things you can do. One thing is power pivot. So power pivot is pivot table like souped up. This is something that Microsoft put out that lets you take as much data as you can fit into RAM, which on a reasonable computer can be about 1 billion rows, and build a pivot table on top of it. This is a regular pivot table. The data source can be, you should be using like 64-bit Excel for that. But if you are, you can basically scale it without limit to sort of as much as will fit in your computer's memory. The other nice thing that's available in Excel is Power BI. So Power BI lets you visualize data sets. It's similar to other BI tools, except it's kind of integrated with Excel. And these are some of the things you can do with it. So this is taking some geolocation data and plotting it across a map. This is taking all geolocation data and plotting it across the map, but now it's at an angle, so it looks cooler for presentations. That's not, this is something you could see maybe in Tableau or other products, but this is right in Excel, which is great, because what's better than Excel? Okay. 100 billion rows. That doesn't fit in memory anymore, probably. Maybe you have a server somewhere you can stick it on, but certainly you're not going to put it on your end user's machine, right? So in this case, there are even sort of more basic questions. One is, how does a layperson look at this? So one option is putting it on Azure and using Power Query. Microsoft Azure is like the Microsoft's AWS sort of competitor, and that gets integrated really nicely into Excel. So if you guys have Hadoop on there, people can actually like access it and pull from there directly. And you can see what that looks like is basically you click through and you have access to your data. This is better than nothing, but maybe not phenomenal. What do you do if a layperson, someone who can't code, wants to model on 100 billion, wants to build a model on 100 billion rows of data? Right now, the answer is really nothing. It's very difficult for them to have the sort of access to a dynamic environment like Excel and just sort of work with it with that large of a data set. So we're building something. That something is tentatively called Rook. And the goal there is to let you explore and analyze like Hadoop-sized data directly from Excel. Right? So what does that look like? Basically, we're providing an interface for people to be able to go into their data warehouse, browse data in a GUI. So again, no code involved, right? Get a sample of that data and actually write a MapReduce script themselves in Excel, right? So then what do? We take that, we compile that, and we run it on your Hadoop cluster, all without needing to interact with a developer. The idea being that if they're building something really simple, if they're trying to find the lifetime value of a shopping cart for their customers, or if they're trying to find some moving average over all of the S&P's history, they can do that directly, right? Like if it were 1,000 rows, they'd be able to do it. So conceptually, there's no reason they shouldn't be able to do it if it's 1 trillion rows. Right, so this is what this looks like. So we're planning to support Hadoop and also SQL, MongoDB, whatever you guys store your data in, and let non-technical people work with anywhere from 1 million rows to 1 trillion rows or more. And specifically, we're just like leveraging the fact that these people are really good at Excel. They can build crazy models with Excel formulas, and that's enough of a programming environment that we can take those models and just run them straight on whatever data set, and just like use the spreadsheet entirely as the GUI. Okay, we're looking for beta users. If you're interested, email us. Our email is info@datanitro.com. You can also hit me directly at ben@datanitro.com. Yeah, thank you guys for listening. So I think I have a few more minutes for questions, if anyone has any. I've gone over a lot of stuff. Yes?
So do you support all the relative reference type codes in Excel?
Do we support relative references in Excel? Yes. So, yes.
Secondly, suppose I launch a long-running computation script. Is there a way to cancel it or get status, things like that?
Yeah, what happens if you run a really long-running computation? That's actually a great question because a lot of lay people will not know how long something will take. And yeah, so you'll get an estimate as to how long it should take, and you can cancel it as well. Yes? Yep.
Can you go over a bit over what Rook does so versus Power Query that you're describing? Is it mainly that I can do Hadoop and MongoDB?
Yeah. So what's the difference between Rook and Power Query? So Power Query is mostly for looking at data. There's no real way to take that and build a computation that's then run. With Rook, we're trying to make that something that you can actually do, like without using code. Okay. OK, cool. Thank you guys very much. My co-founder and I will be around if you have any more questions.